So we have had the 2.6, Alex, that is due tonight. Okay, it was assigned Tuesday. A lot of y'all worked on it yesterday in class. So if you didn't finish that last night, you can finish that today. It's due by 11:59 p.m. Your extra credit in Alex, if you're wanting to do that, remember it's due by 7:20 a.m. and it is all or nothing. If you are struggling with some problems or you've gotten some wrong, each problem was set to 3 attempts, but if you still got it wrong out on your third attempt, it marked it wrong. When you finish the whole assignment, you submit the assignment, then it will let you do a retake, and you'll only have to go back and do redo problems like the ones that you missed. So let's say you missed 5 of them, the retake is only going to be 5 questions. And let's say you submit that and you still missed one, you could retake again, just that one problem. And you can do that as many times as it takes. So the extra credit is set to unlimited retakes until you get that 100%. Then the worksheet for 2.5, the geometric proofs, that was due yesterday. So if you didn't turn that in, you need to get that turned in. And then I was updating grades this morning. I got your logic puzzle grade put in. So if you did not turn in the logic puzzles, today is it. This is your last chance to turn in that logic. Remember, there was 3 puzzles in the packet, and I said just do one of them. Or get it as done as you can, okay? And so if you did not turn in your logic puzzle packet Friday when it was due, today's your last chance to get some late credit on that. So you can see if you have a 0 in Skyward, that means I didn't get it. Then let's see what else. That's the only grade I had time to get in, so I'll work on the other grades tomorrow. And then we have your test tomorrow. Your review is due tomorrow. So your review, remember, is a double daily grade. Okay, so make sure you complete the review. After school today, I will, what am I trying to say? I'll post the key. So I'll put on our Canvas page right under the Blink review, I'll put the key of the review. And I'll put the video links for all the questions, going over questions today will be on there. So you can go back and watch those if you need some extra help. Okay, so let's get started. Who has questions? Your questions today can be on the actual review. Okay, the things on the review are on the test. Okay, if it's a question from like one of our practice or the extra credit, yes, I will still answer your questions, but not every single thing on every single practice and extra credit is on the test. Like the test would be way too long, right? So the test is, like for instance, truth tables. They're not on the test. Yes, we were practicing them. Yes, they're on the extra credit, but they're not on the test. Okay, so if it is on the review though, it is on the test. Okay, so I know I saw like 4 hands shoot in the air. I'll get to all of you. Let's just start on this side. Ian, what's your question?
Number 16 on the review.
On the review, 16. Okay. All right, so number 15, you can see I already went over these in my last class, so it's already filled in. But 15 and 16 were both asking for counter examples. Guys, I don't mind, really quickly, I don't mind if you are working on something else. If you don't need to look at 16 with us, don't do it. Keep working on your Alex or your extra credit or a different problem on the review. But I am recording this to post, so I don't want background noise. And also, it's distracting when I'm addressing the class as a whole and there's all these side conversations happening. Okay, it's distracting and disruptive. So if you want to work on something else, you do you, but do it quietly. Okay, that's all I ask. All right, so both 15 and 16 were asking about counter examples. Counter examples mean prove it wrong. What is something that proves the statement wrong? Okay, so in number 16, our counter example is a drawing. It says draw a counter example for the following statement. It says if M and N lie on line OLO, then M lies on segment OL. Well, line OL goes on forever, right? And the O and the L could be anywhere. Segment OL is only between points O and L. So as long as your drawing has M outside of O and L, not between them, then that's a counterexample because it shows that M can still be on the line, LO, and not be on segment OL. Y'all understand the difference? So as long as you put point M outside of OL, that's a counterexample to this. Good. And then 15, since I'm on the screen, this one wanted 2. Make sure you have 2 counterexamples. And it's the sum of 2 numbers is always greater than 2 numbers. And I think there's supposed to be a B there, greater than the 2 numbers. So for instance, with negatives, if I add 2 negatives, my sum is even more negative. It's further left down the number line. So that is definitely not bigger than the -2 or the -3. If you add a positive and a negative, your answer is bigger than one of them. Okay, -5 is bigger than -6, but it's not bigger than both. -5 is not greater than 1. Does that make sense? Your examples obviously can be different, but you need 2 counterexamples showing that that statement is false, that it's not always true. What else? Yes, Maggie. Huh? 13. Okay. So I did this in last class as well, so I'll just scroll up to it. So remember when you're filling in a proof, okay? So first of all, there was not supposed to be the little M there in this proof part. So I just marked out that M. You can mark out that M. When we have a congruent statement, okay, it's got the congruent sign, it shouldn't have the measure symbol, okay? When we use an equal sign, we're talking about the measure, and that's when we would have the little M on both. Okay, but this is a congruent statement. So we're trying to prove that angle XYA is congruent to angle AYZ, given that ray YA, that I outlined in red here, bisects this angle XYZ. So I always draw and mark things up in my picture, and I would suggest that to you. So if this is bisecting, I immediately know that means that these are the same measure, these 2 little angles, right? How do I know that? That's the definition of an angle bisector, isn't it? That the angle bisector cuts the angle into 2 congruent angles, 2 congruent pieces. So the measures are equal, which means the angles are congruent. So I used the definition of angle bisector to note that the measures of the angles must be equal. And then I use the definition of congruent to say that the angles are congruent. So we normally go straight from statement 1 to 3, but a proof is showing the why. It's giving the justification. Why is that true? Okay, and so we're showing that. Okay. You want me to go ahead and show you 14 while I'm on the page? Okay. So again, your given statement is what we always start with. Okay, so I'm going to start with angle 1 and 2, form a straight angle. Okay, so that's what should be on your first line. And the reason is simply given. Okay, that's what we were told. Okay, then your proof, what you're being asked to prove should always go where in your table? That's going to be the last statement. So you should hopefully have at least those highlighted 3 sections filled out. Okay, that comes from your given and what you're trying to prove. Now, how we get from there to there, filling in the middle here, that's the tough part. We know that a straight angle is 180 degrees. That's the definition of a straight angle. So that straight angle in this picture is ABC. That's the angle that's 180 degrees. And they told me, I'm using information from both of these, that angle 1 and angle 2 together, added together, will equal 180. Okay, that's our angle addition postulate. And that's similar to the segment addition postulate you did in some other proofs, especially in the proofs on the extra credit in ALEKS. A lot of those, I think those have a segment addition one. Okay, so segment addition postulate and angle addition postulate, very similar. One's with segments, one's with angles, but it's saying the two smaller pieces have to add up to be the whole. Does that make sense? Okay, Maren, what was your question? Say what?
Number 3.
3? All right, here are the counter examples. These are really as easy as they look. Okay, some of y'all are just overthinking it. You're making it seem harder. You think, wait, it can't be this easy. It is. It's that easy. What does a counter example do? What did I say on the back? It proves it wrong. So I just need you to show me something. You can draw a picture or you can write words. That was supposed to be in red. Of something that proves this statement wrong. Okay, so it, like I said, you could draw a picture. So no obtuse angles have the same measure. Obtuse angles can have the same measure.
92, 88.
That's not the same measure though.
Oh, shoot.
Okay, so you would simply just draw two, oops, that's an eraser. You would simply just draw two angles. Okay, it doesn't matter if they're next to each other or what. And you would just say, I don't know, 92 and 92. It could be whatever obtuse measure you want, but those are both 92-degree angles. So those are congruent. Obtuse angles can be congruent. Okay. Does that make sense?
Yeah.
Okay. These are pretty simple. If y'all are missing these, you're probably overthinking it. Not everything has to be hard. It's okay. You want to look at any of those others in that section? Now, if you can't think of a counterexample, that might mean it's a true statement. Okay. Remember, if you can come up with a counterexample, it's a false statement. Okay. Some people get confused by that. They're like, well, it could be true. Sometimes it's true. That's fine. It can sometimes be true, but if it's not always true, it's false. If there's a million different scenarios, if one of those is false, this statement is false. That's it. They're out in the room somewhere. You can look around for them.
So are any of these 3?
I haven't checked them out. I will post the key. I can look through them. If y'all want to take the time to look through them all right now, we can. But I will be posting the key after school. Yeah, that'll be posted at like 2:36. Okay.
I need that.
All right. Jalen, what's your question? Jalen, did you have a question? Yeah, bet.
Yeah, I usually do.
Ian, did you have another question? Did you have your hand up a second?
Why would I?
Okay.
Oh.
Okay, so you'll stop making it. Gracie, number 6. All right, I'm going to flip over to the back of the first page. We're going to look at number 6. Oh, no, number 6 is still on there. My bad. Oh, yeah. All right, number 6. Guys, again, I need the side conversations to stop. Thank you. All right, I'm looking at number 6 here. All even numbers are multiples of 4. So you just start thinking of all of your even numbers. A multiple of 4 means like it's divisible by 4 and you get an integer, not a fraction. So what about, is 2 an even number?
Yeah.
If I do 2 divided by 4, do I get a fraction? Yeah, half, right? So it's not divisible by 4. So not all even numbers are multiples of 4. So my counterexample can just be 2. 2 is even, but it's not a multiple of 4. You could have said 6. 6 would be a counterexample. 6 is even, but it's not divisible by 4. Yeah, that's fine. I'm not saying 2 is the only right answer. There's more, but you just have to list one. Were you about to ask a question over there? I thought I saw a hand up. No? Okay, who else? It doesn't have to be on the review. If you have a question on the Alex practice, yeah.
Our questions are different. I don't know. It's not a very big.
On the 2.6 or the extra credit?
The extra credits.
Okay. So I'm looking at the Alex now. you've had 3 Alex assignments. The mixed practice is closed, but the 2.6 is due tonight. The extra credit is due by 7:20 a.m. Okay, so you said on the extra credit,
Yes.
what number?
Well,
Yeah.
I don't, it's, mine's on 33, but like, some of them are different.
Okay,
I don't know.
so you may have noticed, I meant to put an announcement on Canvas and I think I forgot to. But you may have, if you started the extra credit before, you may have noticed it's shorter.
Yeah.
I went and took a few questions out because the questions at the end, I had you doing 2 of each type. And I went down to 1 of each type because I realized I was helping some people in class yesterday and after school yesterday and realized that the proofs in Alex, they are a little nitpicky on them, and some of them are a little bit longer and tougher. So I went down to just 1 of each type. So that's why the number went down on those. So just FYI, if you're wondering why is it shorter. So you said you're 32?
No, mine's 33.
33. Okay, so all of the 33, I mean, they're not going to all be the same. It randomizes the question you get, but they're all going to be similar in the fact of like what you're trying to prove. So we're trying to prove angle measures equal. So I know that I'm going to start with my given information. Now I'm given 2 pieces of information. Okay, so this button will let you just send it to the proof instead of typing it in. So that kind of just saves you some time there. So I'm going to send the first one down there and say given. Oh, or automatically, if you hit send, it automatically fills in the given. That's nice. If you typed this in yourself, you would have to come over here and select your reason and put given. But if you use that send button, then it just puts it. So that's nice. So I put our given information in there. And we are trying to prove at the end that the measure of angle QPS is equal to the measure of angle TPV. Now, every step, this isn't a table, it has you do 1 step at a time and validate it. So every time you type in a statement and select the reason and hit validate, if it goes to the next line, that means it's a true, like, that's correct. Now, it's not going to stop you from putting extra stuff. If it's true and you put a legitimate reason, it's going to let you put it. It doesn't mean that it's necessary. So some of y'all's might be longer than others and you can still get it right. Because some of you may put extra unneeded information, if that makes sense. But if you hit validate and it tells you you're wrong, that means that either the reason you selected is wrong or what you wrote in your statement is wrong. And so you need to go back and take a another look, double check it. Okay, so up here, it says that angle 1 is equal to angle 2, okay? And that 3 is equal to 4, okay? We're trying to prove that QPS, so that's angle 1 and 3 together, isn't it? Y'all agree? I'm gonna go ahead and write that. I'm going to put angle QPS on what I'm writing. I'm not, because I'm not putting a measure. I'm putting the angle addition. I'm saying that it is made up of, it's equal to angle 1 and angle 3. But if that's something it's nitpicky about, it'll tell us that it's wrong. So we'll see. All right, so do y'all agree that QPS is angle 1 plus angle 3? Okay, and that's the angle addition postulate. They call it properties, but we know it's a postulate. Okay, so yep, they want you to put measure. That's it. They are being nitpicky about it. Oops, that's a comma. See, now they let me write it. So yep, that's what I'm talking about, it being nitpicky. That's why I went down to just do 1 of each type, because I would have taken that. I wouldn't be that nitpicky, but that's okay. All right, now we're trying to prove QPS equal to TPV. What is TPV made up of? What 2 smaller angles make up TPV? 4 and 2, right? So it's going to be the same idea here. I'm going to say the measure, already forgot the letters, TPV is equal to the measure of angle 2 plus the measure of angle, Four. also angle addition property. All right, now, because I know angle 1, the measure of angle 1 is equal to the measure of angle 2, I could do substitution, right? Anywhere I see angle 1, I could plug in angle 2.
Yes,
So
yes.
that's the strategy I'm going to use here. In this statement 3 that I wrote, I don't know if it'll let me copy and paste. Let's see. That'll save us some time. Oh yeah, it did. So I'm going to copy and paste that, but I'm going to replace the angle 1 with angle 2. What I literally just did was substitution. Okay, now I can do the same thing up here. I actually could have done that in one step, and I should have done it in one step. I'm doing it in 2 separate steps. It probably would have let me replace the 1 with a 2 and the 3 with the 4. I don't know if it would have. We'll just do it in separate steps. That's fine. Okay, because what I'm trying to get these to be equal to each other. So I want them to equal the same thing. So right now I've got them both to have angle 2, so that's a good start. Now I want these angles to be the same. And I know they are, right? 3 and 4, so they set up here, they're equal.
Wait.
So right here, looking at line 4 and 5, they both have measure 2, but one has 3 and one has 4. So it doesn't matter which one I change. I can change the 4 to a 3 or this 3 to a 4. Both would work. So whatever you picked, that's what I was saying. I don't know if it would have let me do it in one step and change both, or if it would make me break it down. But I'm going to replace the 3 with a 4. Also substitution property. So now, do you see on statement 4, it's 2 plus 4. And statement 6 is 2 plus 4.
Yeah.
And aren't those the 2 angles I'm trying to prove congruent?
Yeah.
So since they're equal to the same thing, they must be equal to each other, right? What property tells us that? It's not a definition. It's one of the properties.
Isn't it transit?
Yes, it's transitive property. Remember when I described it yesterday, I was like, if I find out that Vincent and I have the same birthday, and then I find out that Gracie and I have the same birthday, doesn't it make sense that Vincent and Gracie then must also have the same birthday?
Yes.
That's transitive property. If something is equal to 2 different things, then those 2 things must also be equal to each other. Okay, so I can now write that statement that we were trying to prove using transitive property. And my proof is complete. Y'all follow?
Yeah.
Okay. Now, I will tell you, your test questions with proofs are easier just because they're not blank slates. It is not just empty lines for all your statements and all your reasons. There is a table there, and you're filling in missing pieces from those columns. They're not just completely blank. So you are not having to do it all from scratch like we just did on here or even in our review. Okay, there are some filled in and some blank, and you're just filling in the blanks. So that's going to be easier, right? Okay. And even when you are filling in the blanks, you're not typing, you're like drag and dropping. So there's like choices that you're picking from and filling in those blanks. Okay. What else? Jean, were you about to ask something? I keep thinking I see your hand up over there. Am I wrong? Ian?
If you scroll down to the same sentence.
See if I can zoom in on this. Is that good? All right. Who else has a question? Anybody else have one they want to go over from, it can be from the 2.6, Alex, it can be from the extra credit, from the review,
The
Benny?
review on number 9.
9 on the review. Are you good, Ian?
Yeah.
Yeah, take it past with you. I already forgot what number you said, Benny. What? Benny? 9. Okay. All right, so this is also a proof. I think y'all are more comfortable with the algebraic proofs though, just because you've done so much algebra. In intermediate, you've done algebra. In algebra, you did algebra. So this is kind of second, the solving part of this is kind of second nature to you. It's just really, I have to be able to justify the steps. Okay, so here, again, it doesn't matter if it's a geometric or a algebraic proof. My first statement is going to be my given information. So what reason goes there? Given. Please don't miss that if that's a blank on a test question. All right. And then I know if it wasn't, it is already filled in this example, but if it wasn't, what always goes down here?
Divide.
Where I highlighted the statement, your last statement is always what you're trying to prove. They already have it filled in. I'm just highlighting so you can see. Those 3 highlighted places in your proof should always be filled in. There's no reason to miss those, right? All right, now they've done the steps already. How did they get from statement 1 to statement 2? What happened to that divided by 2? It got multiplied. They used the opposite operation to move terms across the equation. And what you do to one side, you do to the other. Those are those properties of equality. So here they used the multiplication property of equality. If you just wrote multiplication, that's fine. You know what you meant. Okay, that's fine. If you put multiplication property, that's fine too. It is technically the multiplication property of equality. Okay, but you don't have to write all that. All right, now, how did they get from x plus 3 on the left to just x? Where did the 3 go?
They subtracted the 3.
They subtracted the 3. So that is the subtraction. I don't know why I'm putting another R.
Oh, but it's the which are plus.
So that's the subtraction property of equality. We feel okay about that? Now, let me just reiterate, because this is where some people mess up their reasons. They put their reasons on the wrong lines. Okay, your reason is always, how did I get this from the previous information? Okay, how did I get this from the previous information? Okay, so some people are writing their reasons like one line higher or lower than they should be. So it's always from the previous information, how did I get here? How did statement 2 come about? It came about because of multiplication. How did statement 3 come about? It came about because of subtraction. All right, what else? Chrissy? Extra credit, sure. All right, going back to the extra credit, I'm going to look at number 9. And again, the Alex is not going to be the exact same question for everybody, but it's the same type of question. Okay, so here it asks us, suppose the given statements are true, find the other true statements. Okay, so statement A, or the first true statement here, is that Kira's cousin if Kira's cousin is a girl, then the window is above the door. So this is a conditional statement, right? And if P, then Q. And then it says, it's true that Kira's cousin is a girl. Well, isn't that my P? Yeah, the P from that conditional. So they're saying the P is true. And this conditional is true. So that means that the Q must be true, right? If it is a true conditional, meaning that the conclusion depends on the hypothesis, and they tell you the hypothesis is true, that means your conclusion part, the Q part, must also be true. So the window is above the door. Okay, hang on, let me grab the phone, then we'll finish that one. This is verified. Yes. Thank you. Yeah, you're checked out, Linda. Yes, when one passes comes back. So in B, it says, okay, this conditional, if the tires are old, the chain knows how to dance. Nobody said these need to make sense. That's what you'll have to get across. When we're thinking about the rules of logic, if they tell us it's a true statement, we treat it as a true statement. So if the tires are old, then chain knows how to dance. If chain knows how to dance, then my favorite movie is being shown. So if both of those are true, what else must be true? And this is, I think what they're looking for. Remember, I think this was in 2.3 notes that we talked about this. You are in deductive reasoning. If you need to go back and look at those, we learned the law of detachment and the law of syllogism. Okay, those are in deductive reasoning. So the law of syllogism says if P, then Q, if Q, then R, if both of those are true, we can cut out the middleman, right? And then, but this, like, those aren't the same, so we can't just cut that out. So this one's not law of syllogism. Or I'm sorry, this one is. It's how to dance. So chain knows how to dance, chain knows how to dance. So we can cut out the middleman and just say if P, then R. So if the tires are old, then the favorite movie's being shown. That was law of syllogism. It's in the 2.3 notes if you need to review that. Then C says, if Scott likes the milkshake, then the play is a success. So then it asks which of these must also be true. If the play is a success, then Scott likes the milkshake. That is the converse. Okay. If Scott does not like the milkshake, then the play is not a success. That's the inverse. If the play is not a success, then Scott does not like the milkshake. That's the contrapositive, right? So we talked about the conditional and the contrapositive will always have the same truth value. So if you switch the order and negate, so we switched the order, we put the play as the successful play first and the milkshake second, and we negated both, that's got to have the same truth value. Does that help? Conditional and contrapositive always have to have the same truth value. Okay, law of syllogism was that middle one. Okay, if your conclusion of one conditional is the hypothesis of the next conditional, you can cut that middle part. If they're both true, you can cut that middle part out and go straight from the first hypothesis to the last conclusion. And then that first one was the law of detachment. Yeah. On the extra credit or on the review? Extra credit. All right, I'm gonna look at 11. This is a truth table. Again, I'm going to go over this so you can make sure that you understand it for the 2.6 practice and for the extra credit, but you do not have a truth table question on the test. That's why it's not on your paper review. Okay, but I will explain. Guys, please lower your voices if you're having a side conversation. Y'all are getting quite loud. Okay, so a truth table, the P and the Q column, these are all the possibilities. Your P and Q statement could both be true, they could both be false, or you could have one of each, okay? So those are P and Q columns always going to be the same. So then they're asking you, oh, this is a I don't know why it jumped to the bottom, but okay, we got to answer this top part first. We'll get to the truth table in a second. Okay, so we're told that P, the statement P is it is snowing, the statement Q is Anne is wearing a hat.
Oh, yeah.
Consider this argument. Premise one is, if it is snowing, then Anne is wearing a hat. Okay, so they made a conditional, if P, then Q. Then they tell us premise 2, it is not snowing. Well, that would be the opposite of P, right? The negation, so not P. So let's fill in those symbols. So we said that one would be not P. This one would be the conditional, if P, then Q. So the conclusion that they draw is, therefore, Anne is not wearing a hat. Well, Anne not wearing a hat would be not Q, right?
Yep.
So that's the symbol. Now, it is not telling us this is an argument somebody is making. Our final answer down here, is it a valid argument? It's a yes or no question. Some of you can answer this before doing the truth table, okay? But some of you may need to look at the truth table to help establish whether that's a valid argument or not, okay? So they're saying, if it is snowing, then Anne is wearing a hat. It is not snowing, therefore Anne is not wearing a hat. Okay, so that is saying that that's the inverse, right? If you understand your truth values, you know that if a conditional and an inverse don't have to have the same truth value. They can, but they don't have to. So this is not a valid argument. Okay, because the only ones that have to have the same truth value are a conditional and the contrapositive, or a converse and an inverse. Okay, but that is a conditional, and then that would be the inverse. And so that's not guaranteed that that's true. So that is not a valid argument. Now, we still have to answer the truth table because they want you just practicing the truth table. And if you don't understand why that's not a valid argument, the truth table will clarify that for you. So they have filled this in based on what we did in part A. So I need to break this down. So I've got a P column and a Q column. Now I need a conditional P then Q column. Now, we did not look at conditionals in our truth tables in our notes, but if you come over here to example, you can look down here as a similar example, and they'll explain here. See in the truth table, for a conditional, if P then Q, for a conditional, okay, it will only be false when P is true and Q is false. So when the hypothesis is true and the conclusion is false, then this statement is false. That's the only time it'll be false. Every other time it'll be true. So that's the rule that you need to be able to fill in that part of the table. So we're looking for where P is true and Q is false. So P is true and Q is false is right here. That is the only time this will be false. Every other time, I don't even have to understand it. Every other time it's going to be true. The only time that the conditional will be false is when P is true and Q is false. Okay, so now I've filled in that piece. So now I have that truth value. Okay, now this is a compound statement. What does that symbol mean? It means and, right? Okay, and not P. So if you need a not P column, okay, make yourself a not P column. Not P will just be the opposite of P, right? So P was true, true, false, false. This will be false, false, true, true. So now we have the two parts of this and this conjunction. For a conjunction to be true, both have to be true. So here, this is the only one, or no, these bottom two. These bottom two have both parts true, don't they? So that conjunction is going to be true in these bottom two. Now, this is another conditional, so I actually need to add a column for just that part, just that compound. So it's if P, then that's not where I wanted to type that. My cursor in the right place. Okay, so that was P then Q. And not P. Okay, so just this part right here, I've typed in, and we said the bottom one, they are both true, so those are gonna be true. The others will be false. Okay, now it's all of that is this column right here. So if all of that, then not Q. So then I'm gonna make a column for not Q. So not Q is the opposite of Q. So instead of TF, it's FT. Now I have everything that's in this conditional, and we said for a conditional to be false, you have to have a true hypothesis and a false conclusion. So now this is my hypothesis, this is my conclusion. So a true hypothesis and a false conclusion is the only time this will be false. So the rest of these are true. So then to answer that, if you hadn't already answered, is it a valid argument? You have to see this is the line where that happens, because this premise was if P then Q and not P, then not Q. And we said that you have to find the true value of those, and that was this one where it would be false. Okay, so that was not a valid argument.
Yeah, but.
All right, let me stop this video. Review is due tomorrow. Y'all wait for the bell.
I've been.